Using BCD, determine 432 plus 357, giving the answer in excess-3. So here we are going to use BCD code to add these two numbers, and the answer that we get at last, we convert it into excess-3 code. So BCD has its own rules when using it in addition. So be sure to look at all the other papers, because we have solved many questions or rather many past paper questions concerning BCD arithmetic, because some of them they show some rules that should be followed, and for example, for this one you shall see that it is a direct one, but you can look at other papers so that you may watch several questions concerning BCD arithmetic. But to start with, BCD, this is binary coded decimal decimal code. That is what it means. And in this BCD, we represent decimal numbers using 4 bits. So when you want to represent a decimal number, you have to represent it using 4 bits. Another thing you have to know, BCD only represents numbers from 0 to 9. So when you are adding, any number that is above 9 is regarded as invalid BCD. Invalid BCD. And for that case, the number that we get, we add 6 to make it valid. We add 6 to make it valid. So that was just an introduction about BCD. Let's look at our question. We are told to add 432 and 357. The first thing is to convert these two to BCD. So 432 to BCD is, every digit we write it in 4 bits. So 4 is 0 1 0 0, 3 is 0 0 1 1, and 2 is 0 0 1 0. Then 3 5 7, we have 0 0 1 1, we have 0 1 0 1, and we have for 7 is 0 then 111. Then these two we had them. So in BCD, another thing, you add every group alone. So every group of 4 is added alone. If it goes beyond 9, we add 6, where 6 is equivalent to this. We add 6 to make it valid BCD. So if any number goes beyond 9, we shall add 6. That is for each group. So let's add our numbers. We use the normal binary addition. So 0 plus 1. 0 plus 1 is 1. We have 1 and 1, we have 0, we carry 1. 1 plus 0 plus 1, we have a 0, we carry 1, and we have a 1. So in this case, when this number for us in the first group, when you convert it, you find that it is 9. So this number is 9, so it is not beyond 9, so we are not adding any number we are not adding 6 to make it valid. Then in the second group, we have 0 carry 1, 0 carry 1, 0 carry 1, 1. And that is, when you convert it, you get 8, which is valid BCD. Then lastly we had the rest, which is 1 1 1 0, and this is 7, so it is valid BCD. So here we are not adding any number, we are not adding 6 to make it valid. So this is our addition, but this one is in BCD code. Our question requires us to give the answer in excess-3. So to get excess-3 of BCD code, to every group we add 3, and the 3 we add it in binary form, which is 0 0 1 1. So for this number, we add 3 to every group, and we add also 3 to this group. So every group you add 3. So when we add 3, we have 0 carry 1, 0 carry 1, we have 1 1. Then we have 1 1 0 1, we have 0 carry 1, 1 plus 1 is 0, 0 plus 1 we get 1, we had carried 1. We have 0 carry 1 1. So our answer will be 1 0 1 0, 1 0 1 1, 1 1 0 0, and this is in excess-3. So that is our solution for that question.